Characteristics of rational functions. Let us try to understand the characteristics of some rational functions with three different examples. We'll find if there are any wholes, x intercepts, y intercepts, horizontal asymptotes, vertical asymptotes, domain and range of the functions. You can always look into playlist with hundreds of similar videos where we'll also discuss oblique asymptotes and many other cases. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. The question here is from our student in Germany. Let's try to understand how do we find different characteristics of rational functions. We'll begin one by one, taking each example. So we're going to find what is a whole, right? Where it is, if at all it is there. We'll find what is x-intercept, y-intercept, horizontal asymptote, vertical asymptote, and domain and range. Now, when we talk about a whole, it really means we have a common factor in numerator and denominator. So once this common factor cancels, then we have a whole, right? X-intercept is a value where the graph crosses x-axis. So here y is equal to 0. At y-intercept, we'll substitute x equals to 0. Very simple. Horizontal asymptotes, depending on the equation, we are basically finding when x approaches infinitely large value, does y approach a particular value? Now, x could also approach negative infinity, and y could also approach some other value, right? A equation can have two horizontal asymptotes. Most of the time, we see one only, but there are two sometimes. Also, important to note here is that the graph of the function can cross horizontal asymptote, which is not known to many students. Now, when we talk about vertical asymptote, then what we do is we first simplify, right? So after simplify, the denominator is not equal to 0, right? That gives us vertical asymptotes, correct? Domain and range. So we'll see domain range, kind of sketch the graph, and then it'll be absolutely clear. However, in domain, we will not include the whole and we will not include the vertical aspect. Makes sense, right? So those are the points which are not included for domain, right? And if the graph is not crossing the horizontal asymptote, then the range will not include horizontal asymptote because we are approaching that value, correct? So I hope with this concept in mind, we can easily answer all the three questions. I'd like you to pause the video, answer, and then look into my suggestion. Also, follow our playlist for more practice questions. And of course, you can always join our classes. Email globalmathinstitute@gmail.com and be the best. Perfect. So let's begin with the very first question, which is given to us as g of x equals to x times x plus 1 over x squared minus x. It's a good idea to simplify. So we'll factor the denominator where x is common and we get x minus 1. So you see there's a common factor which is cancelling. This is going to give us a whole, right? So we should write here that x is not equal to 0 once we cancel, right? Second, also in the denominator, we are left with x minus 1. So it is not equal to 1 also, right? So I'll rewrite this as x plus 1 over x minus 1, where x is not equal to 0 or 1. Both are not there. But that gives us a couple of characteristics, and the very first one, which we found here, is whole, right? So let me change things. So we'll say, well, the whole here is at x equals to 0. So what happens when we put 0 here? So to find the whole, I will substitute g0 in the simplified expression, right? So that gives me 0 plus 1 over 0 minus 1, which is minus 1. And that really means the whole exists where the value is 0 minus 1. Does make sense? So this is how we'll find the location of whole. Is that clear to you, right? Perfect. Now, the x-intercept. So x-intercept, as I said, is where y equals to 0, right? So we are always going to use this particular equation to further write down the characteristics, correct? So x-intercept means y is 0, means numerator is 0. So that implies that x plus 1 equals to 0, or that gives you that x equals to minus 1. So the x-intercept is basically is at x equals to minus 1. You could also write this as a coordinate point minus 1, 0. Makes sense, right? Now let's look into the y-intercept. So y-intercept means put x equals to 0. So in this expression, if I put x equals to 0, then I get what? Well, substituting 0 in this expression, we get 1 over minus 1 as just we did, right? And the value becomes minus 1, correct? So we know that the the y-intercept should be at x equals to 0 and y equals to minus 1. However, we know this is a whole, right? However, we know that this is the whole at x equals to 0. So therefore, we cannot actually get a y-intercept. You get the idea. Because there is a hole. So there is no y-intercept. You get the idea. So it's a very important point to understand. Since there is a hole there, there's a discontinuity, and therefore the y-intercept will not exist for the given situation, right? Now let's look into the domain range, but before that, vertical asymptote. So vertical asymptote denominator is 0. So let's rewrite denominator, which is x minus 1 equals to 0, will give you x equals to 1, and therefore we have a vertical asymptote which is x equals to 1. Makes sense. Now let's come to domain, right? So domain of this particular function is x belongs to real numbers. However, two values are excluded. One is the horizontal, one is the whole, and the second one is the vertical asymptote. So x is not equal to 0 and 1 as already mentioned, right? Now let's get to range. So range y values will be y belongs to real numbers. However, this graph does not cross the horizontal asymptote, and therefore, in this particular case, the horizontal asymptote is going to be 1, which is the coefficients of these, right? Y is not equal to 1 and minus 1. Minus 1 is because of the whole. So I missed horizontal asymptote earlier. So let's see how do we find horizontal asymptote from here, right? Now, whenever the coefficients are same for numerator and denominator, in that case, horizontal asymptote is basically equal to ratio of leading coefficients, right? So here, ratio of leading coefficients is equal to 1, right? So horizontal asymptote is y equals to 1, right? Because the leading coefficients are 1, right? Okay. I'll show you the technique in the next example. Great. I hope everything else is clear. We'll look into horizontal asymptote in more details later. Now let's take up the next example, which is question number 2. So here we are given a function f of x equals to minus 3 plus x over 2x minus 6. It can be factored. So we can take x common, right? So it's good to write x first, right? So let me write first like this, x minus 3, right? Over 2 common, right? So we get x minus 3 here also. Since x minus 3 cancels, we get half, and we know that x is not equal to 3. So that is our function. Now this half is a constant. Now in this particular case, as you can see, there is only after simplification 2. So in this case, what is happening here is that the y value is always half. So if I sketch the graph, it will look like this. So except for at 3, you'll have a hole, right? So y is equal to half. So this coordinate point here is 3 half. So we have a hole at x equals to 3, the discontinuity, and the value is half. So in the hole, we have to give the value. Now you can see that this graph also crosses the y-intercept, right? So there is no x-intercept, but we have a y-intercept, right, which is at 0 half, correct? Because y is always half. And here we do not have asymptotes, right? Is that clear to you? Correct? As far as the domain is concerned, domain is x belongs to real numbers, but x is not equal to 3. The range, as you can see, range, the y values, will be y is equal to only half, right? There's only one value of y. Do you see how different this particular function is with respect to the other one, right? So here, y has got exactly one value, which is half. Okay, I hope it is absolutely clear, right? Now we are going to take up the third example. You can always email me on globalmathinstitute@gmail.com to learn more. Third example is, I think, clear to you. You may first simplify the expression, which is x squared minus 4 over x plus 2. Factor the numerator, you get x plus 2 times x minus 2. It is difference of squares, right? Over x plus 2. As you can see, x plus 2 cancels, and you get an expression which is x minus 2, and of course x is not equal to minus 2. So when you cancel out a common factor, what do you get? You get a whole, right? So let's write down the characteristics. We have a whole which is at x equals to minus 2, right? So if I plug in minus 2 here, so h of minus 2 will be, I mean, we're talking about the whole position, right? Will be minus 2, which is minus 4. So the whole basically is at x equals to minus 2, and the y value is minus 4. Makes sense? It does not have any vertical asymptote since it is a straight line and there is nothing in the denominator. The factor cancelled, resulting into a whole, right? So x minus 2, I can always draw the function which will look like this with a discontinuity at minus 2, right? So x equals to minus 2, right? The y value of minus 2 is here, and so the graph actually goes like this. Makes sense, right? So this is minus 2, the y-intercept, and this is our whole, which is at x equals to minus 2, the value is minus 4, correct? So that's the whole. And here we have an x-intercept. We can find the value for x-intercept. Substitute y equals to 0. So we get y equals to 0 means x minus 2 equals to 0, x equals to 2. So that value, x equals to 2, is the x-intercept, right? So the x-intercept is actually equal to, you can have a coordinate point or you can write x equals to 2. So we get 2, 0. Makes sense? Vertical asymptote, none, right? Horizontal asymptote, right? None. So we can write no vertical asymptote, no horizontal asymptote. Is that clear to you? Since the factors cancelled out. Now the domain and range part. Domain is x belongs to real numbers where x is not equal to minus 2. And the range is y belongs to real numbers where y is not equal to minus 4. Because that is the value of the whole. You get the whole idea. So as you can see here, when we look into these functions, we can clearly see that whole is a restriction and it restricts both x and y values, right? So that's why finding the value of whole is important. We also wrote here y equals to half. In this case, because there is half other ways, right? So that's why it's just half. And the first case, when there was a whole at 0 minus 1, we knew y is not equal to minus 1. So I should have written y is not equal to minus 1. Okay. Sorry. So in this case, a y value is not equal to minus 1, right? Because at minus 1, there will be a whole, right? So that's the correction. And again, coming back to the horizontal asymptote, we can actually, if x is very large, then g of x basically is equal to x over x, right? So which is 1. And therefore, for x approaching positive or negative infinity, 1 is negligible, right? So the graph will be approximately x over x, right? Which is 1. And therefore, the horizontal asymptote is y equals to 1. So just summarizing the horizontal asymptote, which I missed earlier while describing. I hope with this you have learned how do we find the whole x-intercept, y-intercept, horizontal asymptotes, and the vertical asymptotes. Also, domain range, once we have done all this, is very clear. And you can always sketch the graph. So as an extension, I'll write here sketch graph. So I gave you approximate graphs for each one of them. I'd like you to sketch them and confirm. Perfect. I hope that makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. अमिता हो गया